Hi, I am Mr. Sadanand Sarve. I am the assistant professor at Vidya Vikas Arts Commerce Science College. So today we are going to learn about the basics of operational amplifier. Okay, so we'll start now. So what is your operational amplifier? So operational amplifier, it has two terminals. First, two input terminals and one output terminal. Two input terminals are, this is non-inverting terminal, this is inverting terminal, and this one is your output. So what is the advantage of operational amplifier is that it can amplify DC signal as well as AC signal. And here we have to apply the input. Suppose if you apply input to the non-inverting terminal and inverting terminal, then what will be the output? Output will be the gain multiplied by difference between this non-inverting terminal and inverting terminal. So here that is output. It is equals to the gain into the difference between in non-inverting terminal voltage and inverting terminal voltage. So if input supply is given to suppose this non-inverting terminal, then output will be appears to be positive. There is a no change in phase. If you supply the voltage to this inverting terminal, then it changes by 180-degree at the output. Okay, that is the difference between non-inverting terminal if input is given to the non-inverting terminal and if it is given to the inverting terminal. Okay, so that is operational amplifier. Then question arises that why it is known as the operational amplifier. Okay, so it is known as operational amplifier because with this operational amplifier we can perform some mathematical operations like addition, subtraction, integration, differentiation. So this mathematical operation can easily perform by using operational amplifier, hence it is known as the operational amplifier, or we can say it as a op-amp. Okay, so this operational amplifier advantage is that it has the very high gain. So it is an open loop. Open loop means there is no feedback from output to the input. In open loop, it has the maximum gain. But if you supply some feedback to this operational amplifier, feedback means what? You have to supply this output to this input by some feedback network. If you apply some feedback network here and this output is up with that feedback network supplied to the input, then this operational amplifier can be used as a filter, oscillators, and comparators, regulators. So that is the advantage of your operational amplifiers. Next we will study about the block diagram of operational amplifier. So this operational amplifier is nothing but it consists of four stages. First stage is your input stage, second is your intermediate state, third is your level shifter, and fourth is your output stage. So these are the two inputs, non-inverting terminal inputs and inverting terminal input, and this is your output. Between these in two inputs and one output, there are four stages. First is your dual input balance output differential amplifier, second is your dual input unbalanced output differential amplifier, third is your level shifter, it is your emitter follower constant current source, and fourth is your push pull amplifier. Now will question me that what is this dual input balance output differential amplifier. Actually, first of all, let us see that what is differential amplifier. Differential amplifier means it consists of two transistors. Suppose this is transistor Q1, this is transistor Q2. These two transistors are selected such that their parameters are closely matched with each other. Okay, so suppose this is transistor Q1, which is here it is in common emitter mode, this is also in common emitter mode, and this is the resistance Re, which is common to the both transistor, and it is applied to this minus VEE. These are the biasing condition, plus VCC and minus VE. Suppose this is plus 12 volt, this will be equals to the minus 12 volt. This plus VCC connected to this resistance across collector to the collector terminal to this transistor. Similarly, it is with collector resistance, it is connected to the another transistor. Here suppose input voltage V1, VS1, AC input voltage source. Here AC input voltage VS2. This is supplied to this resistance to the base of second transistor. Here VS1 is supplied to the base of first transistor through this resistance. So question is why it is known as a balanced output and why this is known as unbalanced output. If we have to measure the output voltage, such that if output voltage is measured across these two collector terminals C1 and C2, between these two collector terminal, if you measure the output, then it is known as the balance output differential amplifier. And it is known as differential amplifier. Why it is known as differential amplifier? Because it amplifies the difference between Vs1 and Vs2. Suppose this is your non-inverting terminal. This is your inverting terminal. Okay. So, and if you measure the output at one of the collector with respect to the ground, output is measured at one of the collector with respect to the ground, then it is known as the unbalanced output. And dual, why it is known as dual input? Because it has two input source, Vs1 and Vs2. So that is your dual input balance output when output is measured across both the collectors. If output is measured across one of the collector with respect to the ground, then it is known as your dual input unbalanced output differential amplifier. So what is your first stage? First stage is your dual input balance output differential amplifier. So what is the use of that first stage? It will provides the maximum, or it establishes the maximum gain of this operational amplifier, and it has the high input resistance. Then what is your second stage? Second stage is your dual input unbalanced differential amplifier. So what is the advantage of second stage? Now it has two inputs, but we have only single output. So output measured across the collector with respect to the ground. Then third stage is your emitter follower. So what happens due to this intermediate state? There is a the your DC source, DC voltage is well above the ground level, and we have to make it to the zero. We have to use this level shifter. So it is a emitter follower constant current source. That is your third stage, and fourth stage is your output stage. It is your push pull complementary amplifier. Okay, so what is the advantage of output stage? This output stage will provide you the maximum output voltage swing, and it establish the current of that operational amplifier. So this is your block diagram of an operational amplifier. Okay, to here in we will stop now. So what we have learned is that what is the symbol of operational amplifier? It has two input terminal, one is non-inverting, second is inverting, and single output. And why it is known as operational amplifier? Because it performs the mathematical operation. And what is the equation for this operational amplifier? Output voltage is equals to gain multiplied by the difference between the two input voltage source V1 and V2. Here V1 is positive because it is if it is applied to the non-inverting terminal, and V2 is applied to the inverting terminal, that's why it is a negative, because there is a change in phase by 180 degree. And this is the block diagram of a operational amplifier. It consists of four stages. Okay, we'll stop here. Next part will be continued in next lecture. Okay, thank you. We'll switch off this. Stop record.